Morning, everyone. We'll just take another 2 minutes. We'll just wait for some more participants to come in and then we'll begin. Hello, we're just waiting for some more participants to come in. So I'll just take another minute and we'll begin. Okay. Let me start with a question. How many of you here are aware about SDR, software defined radio? You can raise your hands. You have an option in the WebEx to raise your hands. Okay, great. Okay, so very few, I believe. Yeah, nice. Okay, so SDR stands for software defined radio. You might have experienced radio equipment, in your daily lives. So in your childhood, you might have seen, the common way to. I mean, not only your childhood, even now, you can see that there is a AF, FM, and AM radios in your cars, right? So maybe in your childhood, you might have seen something like a pocket radio or something like that. So if you see about these radios, these are primarily receiving antennas, right? I mean, these are receiving devices. So which means there will be a central transmitter which is transforming radio signals, and your FM radio would probably receive the signals, and it is converting it into audio. So that's the primary, or that's a very basic kind of radio device that all of us are quite well versed with. So now, coming to the SDR. So SDR is also a very small device. It's a very simple device which is available in the market for the average guys. What you can do with an SDR is that you can convert into either a transmitter or a receiver. So most of the times we always have receivers at our end, but not transmitters. So if you have ever used a walkie-talkie or some kind of other radio equipment, then that's a classic example of how you can transmit signals, and you are also able to receive signals. And then when it comes to complex connectivity, then your entire Wi-Fi, which is your home Wi-Fi, which runs on 2.4 gigahertz, and your mobile communications, which are working on 3G, 4G, 2G, whatever it is. So these are all the examples of radio communication. So simply put up, radio communication is anything which transmits data over a wireless medium. And then when it comes to SDR, SDR is a device which can help you either transmit data or receive data, or do both simultaneously. So that depends on what kind of SDRs you have in your hand. So there are certain kind of cheap SDRs, or I would say budget SDRs, which are like they'll cost you less than 15,000 or 14,000 bucks, but they are mostly limited in the kind of abilities that they have. So let me just show you. Let me just share my screen and show you some of the examples. You should be able to see my screen in a second. Let me know. Yeah. So the most budget SDRs will be something like what we call as a DVR or DVB. Okay. So these are like the most budget SDRs. This will cost you only a couple of couple of thousands actually. So 2,000, 3,000 rupees, you will get a small device which is basically called as a RTL SDR. So these are greatly limited in the amount of frequencies they can actually scan. So yeah, these are also the examples of. These are little bit expensive. The ones that I'm showing you right now, Nulek. So what these can do is, they have a limited frequency. For example, in this case, you can see that this device will cost you somewhere around 5,000, or 6,000 rupees, and they can, basically you can basically tune any frequency from 25 megahertz to 1700 megahertz. So this is like it's an extension to your FM radio. So because your FM radio will not go more than what like 20 or 70 bandwidth of frequencies. Like you start at around 90 97 megahertz and you end at 108 megahertz, right? So it's a very small bandwidth to actually listen to. So if you want to listen to much larger frequencies, I mean larger in the sense much larger bandwidth, then you typically buy this RTL SDRs. As you can see, it goes from 25 megahertz on the low end and 1.7 gigahertz on the highest end. But again, the problem with RTL SDRs is that you can always, you can only use it to listen. But the advantage that it gives over a typical FM radio is that you can use it to actually program something. I mean, as you can see, all the wireless data is not gone in the same way, right? I mean, not every radio signal out there is going to be an audio signal. So if you want to decode the data in a particular way, for example, between 25 to 1700 megahertz, you can transmit audio signals, you can transmit Morse code, you can transmit video signals, you can transmit binary code, or you can transmit any other code. So how do you actually encode that data? How do you send it on a Wi-Fi? How do you decode that? So these are the minimum principles that make an SDR, or that makes this kind of radio equipment. So the advantage that the SDRs actually give you is that they'll provide an ability to receive any type of Wi-Fi signal in the given range, the wireless signal in the given range, and the data embedded inside that radio signal can be decoded as you wish, depending on what kind of program you actually write. So for writing the program or working with the programming, so we have something called as GNU radio. So what GNU radio does is that you can this is the software, the GNU radio, which you can actually connect to various SDRs. I mean, from the very low end budget SDRs to the top end, the SDRs which will cost you like lakhs. There are some SDRs which will cost you around 14 15 lakhs also. So I mean, whether it is a top end SDR or whether it is a 4,000 5,000 wala SDR, doesn't matter. GNU's radio supports a wide variety of equipment. So you can connect that equipment and you can actually, as I said, you can decode the data and apply various sorts of algorithms, tweak the signal, do a lot of work with whatever radio signals that you can find. So you can also use GNU radio to basically scan all the signals, latch on to a particular frequency, and then in that frequency whatever data is incoming, you will be able to decode that. At the same time, if your SDR supports it, then you can also use this to transmit the data. So transmit the data in the sense, for example, you have let's say that you have a text file. Now you want to experiment sending that text file in binary to on radio, or you want to broadcast it. So you can write a program in GNU radio where you can take that binary file, convert into a you can take that text file, convert into binary, or Morse code or whatever it is, and then you can apply the proper encoding formats to transmit that signal, so that anybody with a receiver receiving SDR on the other end, they'll be able to receive all of this data out, and they'll be if they're smart enough, they'll be able to figure it out on their own. So GNU radio also supports where you can immediately identify what kind of file you are actually receiving. So I mean, combined with Wireshark, I'm sure you must be aware of this Wireshark tool. So GNU radio combined with Wireshark, I mean, for example, you are at the receiving end, then you can use this Wireshark tool, which is a packet sniffer tool. You can use this packet sniffer to actually whatever the signals that you have decoded, you can use this Wireshark to basically read the data inside it, if it is network data, or Wireshark also supports a lot of radio communication protocols. So if it is a generic protocol that you are using, you should be able to decode the data on the fly. So Wireshark is another tool which is most probably used along with the GNU radio. Yeah. So that's introduction to SDR, software defined radio, and how you can use it. So some of the common principles that you should be knowing about SDR. is about antennas. Depending on what kind of frequencies you are using, it may be required that yeah, let me just see. Yeah, as I said, depending on what kind of SDR you are using and what kind of frequencies you are expecting to work with, you might have to use certain kind of antennas. So typically saying, I mean, you might have seen this image of an antenna, which is very common. So this is the kind of antennas you will, always have in your wireless routers or in your home routers. So these are called omnidirectional antennas, and these do have specifications. So some antennas, although they look like the same, not all antennas can comply with the kind of frequencies. So for example, for 2.4 gigahertz and 5 gigahertz, you might be using these frequencies. But if there is any specific frequency that you want to work with, or if you want a directional antenna, then you'll have to go with other types of antennas. So let me just show you a picture. Yeah. So as you can see, you are looking at a square type of antenna, right? So this is the kind of antenna you will use if you have a directional, requirement. So let's say that the other party or the sender is actually sending you a signal using a directional antenna. So you'll have to also use a directional antenna to actually receive all the signal. And one common principle that you should know when you are working with SDRs is that the relation between the wavelength and the frequency. So some concepts of frequencies are very much necessary when you are working with SDR. So simple principle is that wavelength is inversely proportional to frequency. I'm sure most of you are aware of that. What it basically means is that the higher the frequency, the smaller the wavelength is, which basically means that you might have omnidirectional antenna which is like very long. I mean, at a lower frequencies, you want an antenna which is very long, because it needs to capture the entire wavelength, right? As I said, on the lower frequencies you will have a very high wavelength. Yeah, so in order to capture the entire, from top to bottom part of the wavelength, you will mostly require a larger antenna. But the higher the frequencies that you actually use, the smaller the antenna it actually becomes, because you'll have to focus your energy at a particular point. So that is the reason you might see something like this, which are directional antennas. You can also use omnidirectional antennas, but using a directional antenna will make sure that you can your bandwidth will be higher. So which means the quality of the signal will be much higher using a directional antenna than using an omnidirectional antenna. Yeah. So these are some common principles that you should be aware. Yeah. So again, as you can see on the screen, so these are some of the SDR softwares that we can actually work with. So I'm just giving you the introduction of what all I mean what can do with an SDR. So as you can see, the advantages of SDR technology is uh, you can work with very high levels of performance. Most of the SDRs out there. So you have the ability to change performance by updating the software. You can reconfigure radios by updating software, or you can use the same hardware platform for several different radios. So as I said, the primary reason why we use SDRs is that a single device can actually be used in multitude of ways. So for example, if I buy an SDR, for example, the one that you are seeing on the screen right now. So if you see this HackRF Great Scott Gadgets, so this one, or I would say Blade RF, is much better. So if you use Blade RF, then that same device can be used as a Wi-Fi router for you. I mean, you can use that Blade RF, or I mean, Hack RF is actually, it's not a duplex capability, which means that you cannot transmit signals and receive signals at the same time. So you can do one at a time. So that's the limitations of Hack RF. But if you buy a Blade RF, which is a little bit more expensive, you can do both the transmission and receiving at the same time, which is very much necessary for if you want to make it work like a Wi-Fi radio or Wi-Fi router, right? So you can configure that to act as a Wi-Fi router where you can transmit and receive packets, or by simply changing the software or the firmware of the Blade RF, you can simply convert into a BTS antenna. So BTS stands for base transceiver station. So BTS is a common word used to say it's a mobile tower. So mobile tower, in the sense, you can actually use your Android or iPhone to actually connect to this BTS. So if you have a sample sim, or valid sim card, then you can configure the sim card to actually connect to your own BTS antenna that you made. So you can make a 2G BTS station, or a 3G BTS station, or even a 4G BTS station. You can actually make 5G also with blade RF. So what I'm trying to say here is, these kinds of SDRs, you can configure it with just a click of a button. So at the click of a button, from Wi-Fi router, it immediately becomes as a BTS station. And then at the click of a button, you can configure that to work as a walkie-talkie. So if there are two persons who are having blade RFs, then they can actually transmit signals over radio, and convert that into audio. So you can convert, I mean, you can connect the SDR into your laptop and use your laptop's microphone and your speaker to actually make it as a walkie-talkie. So, I mean, these are all the things that you can actually do at the click of a button. So just by uploading a different firmware, you have a different functionality. So that's the robustness of a software-defined radio, or why SDRs are very much very interesting to actually work with. So instead of buying 10 devices, because you have various workings, you can buy a single device, and based on your usage, you can use it appropriately. So that's the advantage of having an SDR. Sorry, you're able to hear me now? Let me just check my. Okay, I've just moved closer. Okay, I'm audible. Okay, great. So if I'm not audible, maybe just check your network also, because I believe other participants are able to hear me. Okay. Yeah. So that's the introduction to SDR, or the advantages of the SDR. So you have various SDRs available in the market. Yeah. So as you can see, what do you need to set up an SDR? So as you see, the SDR device is most important. As I said, depending on your budget, you can either buy an RTL SDR, which are the cheapest ones. Most of the RTL SDRs will you will be able to purchase within 10 or 12,000 maximum. So the starting price of some RTL SDRs is around 2,500 rupees. And if you want to get a good SDR, it will cost you somewhere around 20,000 to about 30,000. For example, the Hack RF, I guess you'll get it for around 20 to 24,000 in India. So these are the normal SDRs. Or as I said, Hack RF is a little bit better than RTL SDR. And then if you want the best SDRs, then you should look at USRP devices by ETUS Research, which is available in India. Otherwise, you can also get a Blade RF. And there is one more new player in the market, that's called a Lime SDR. So even Lime SDR, I believe, is now available in the Indian market. So you can also buy an Lime SDR, which has duplex functionality, which means you can send and transmit signals at the same time. So first of all, you need an SDR board. So once you get an SDR board, obviously, as I said, antennas play a very important role. And then you will need a computer running Sdr software. So these SDRs are not autonomous, at least most of the times. So you will need to connect to your laptop or desktop to configure the SDRs. So it is possible that once you configure your SDR, you don't have to, you no longer have to connect it with your computer. So you can also use it as an independent device, but to configure the SDR, you might require a laptop or an SDR. Sorry, laptop or a desktop. So yeah, that's about it. Yeah, as I said, these are some of the examples of the SDR software that you can actually work with. So you have SDR, Studio One, GQRX, Linrad, SDR Radio, HDSDR, SDR Sharp, and yeah, GNU Radio is one thing that I've told you, right? So GNU radio is a very robust. It requires a little bit of learning, so it's not very easy at the beginning. But JNU radio, it needs some learning. While the SDR, GQRX are pretty straightforward. GQRX, I believe, if I'm not wrong, you will also get a command line option. So just using a command line, you can tweak the frequencies, and you can send the data, or decode the data just through command line. Yeah. So yeah, what you can do with SDR. So as you can see, these are some examples or use cases that you can do with SDR. You can receive or broadcast radio. You can do amateur radio. Amateur radio is like, you can it's like a ham radio or a walkie talkie, but over long distances. So all you need is, you need to have a proper antenna. So usually, depending on the frequency that you use and the antenna you use, you are typically limited to a certain meters, or certain kind of distance. So most of the SDRs, you should be, I mean, by default, you should be able to transmit within 50 or 100 meters of radius. But if you want to go over 100 kilometers or more, then you will need to see how do you boost the signal, as well as what kind of antenna you would actually require. But here I would also like to give you a disclaimer that if you're participating in the hackathon, and for level 1, level 2, it is fine, but level 3, if you successfully go to level 3, then you'll also be working with Lime SDR or a hack RF or something with your hand. So at that time, please be very careful. You should not broadcast any signals outside the given range. The given range is typically your home location. So if you are working at your home, make sure that your signal strength is not crossing the borders of your house. I mean, a little bit here and there is fine, but if you transmit with a much higher signal, where I mean, there is a possibility that people, or your neighbors will have disturbance, or interference. I mean, you might be causing some kind of interference to your neighbors. So it is also possible that you can accidentally, or if you intentionally make SDR as a jammer, or if you're transmitting some signals at 2.4 gigahertz or 2.2 gigahertz, or any other frequency which is actually being used by mobile communications or BTS stars, then you might be interfering with mobile communications, which is illegal. And you're liable to be prosecuted by law if you're causing any interference to mobile communication. So the mobile communication companies can actually sue you. So please make sure that when you're working with SDRs, always make sure you are doing it at a very small radius, and you're not using too much power. So don't use any kind of bandwidth boosters, or something like that, which can cause interference to your neighbors. So it's, as I said, it is illegal. So whenever you're working with SDR, you should always look at the local, state, and the Indian regulations that we have. You should also look at what are the licensed bands inside the country, and if there is a licensed band, then you should not transmit any data on that licensed band. So for example, even if it is radio, for example, if you're talking about FM radio, let's say that some 1 or 2.6 or whatever it is, let's say there is Red FM which is broadcasting on that. So if you broadcast on the same frequency as FM, I mean, big city, or Red FM or something like that, then Red FM can actually sue you, because it's illegal to broadcast something on their frequencies, because they have already bought this frequency by paying certain amount to the government, right? So the government will definitely take necessary action. So just make sure that you don't broadcast any signals unintentionally or accidentally also. So just be very careful when working with SDR. But otherwise, if it is an unlicensed band, and if you're free to use those frequencies, then you can definitely broadcast it. You can use it to test various use cases. So as I said, you can use it for amateur radio, where you can talk with the other person using Morse code, or you can also send voice signals. So it's just like a walkie talkie. So you can also use this to you can also use this as a radio astronomy, depending on what kind of antennas and sensitivity you have. You can track ships via AS transmissions. You can track aircraft via MODES transmissions. Tracking aircraft is like that, if an aircraft is actually flying over your city or over your location, so the flights actually do transmit a specific code. I mean, just for I mean, it will be very interesting if you can catch those, and if you're able to identify what aircraft is actually flying above you. So even though you're not able to see it, you should still be able to know that there's an aircraft flying above you. So that kind of use cases is what you can do with SDR. So it is very interesting. So you can also set up a DRM transmitter. You can build a GSM network. You can experiment with LTE. You can also use this as an RFID cards or something like that. You will require special additional devices, but yes, you can also use that as an RFID. So you can also see how global navigation satellite systems work, what kind of data you can actually receive from the satellites. You can also connect to NOAA weather satellites, and you can actually get a picture of your country's weather map. So you can just receive all the signals of the entire weather map. So you'll get a very high resolution weather maps. And I believe there are certain satellites which are made open by NASA, where you can actually get pictures of outside the telescope, or something like that. So it depends. You just check with NASA. I believe one or the other day they actually make it open, which means you can receive those signals and you can get a high resolution images downloaded to your system. So these are all the some of the examples that you can actually do with SDR. So that's about the introduction. So if you have any specific questions, you can just let me know. uh, Otherwise, we will move on to the actual hackathon. Yeah. Okay. So coming to hackathon, yeah. So as you might know, today is your level one SDR hackathon. So I hope everybody has, I mean, all of those who have registered, you should just go and visit sainyaranakshatram.in website. You have all the instructions over there. And if there are any further instructions, we will just communicate to you shortly. You will receive an email shortly if you have already registered for today's hackathon. So yeah, so today's level one hackathon is all about MCQs. I mean, you will not have any complex questions. This is a filtration round. So you will be answering about 100 questions in a limited amount of time. So whoever scores or answers correctly most of the questions, they will be selected to level 2. So how many people will go to level 2? I believe it will be communicated on a later day. So you can just attempt all the questions as much as possible. So today's questions will mostly revolve on very basic knowledge that you have on the SDR. So some of the concepts that we discussed just now, and some little bit complex questions will also be there. So you can use that. But you can use. Most of the MCQs will all be of very basic questions. So, and the level 2 will have a little bit hands-on challenges, but level 2 will not require any hands-on the actual SDRs. I mean, you don't have to have any SDR device within your hand, but you should be thorough with the concepts of the SDR, because you will be using these things virtually. So virtually in the sense that there will be files that you'll have to download, you'll have to analyze, and you'll have to decode the signals, or identify different kinds of signals. So that's the kind of questions you can expect on level 2. So on the level 3, you will be asked to make some application which works on an SDR. So which means you will be working hands on an SDR. Probably you'll be working with HackRF or Lime SDR. That will be communicated to on a later date. So if Lime SDR or HackRF is given to you, so you should be building something on top of that, or there will be some challenges which will be given to you, which you will have to solve by actually using the SDR. So it's possible that there is a signal that is being transmitted. You'll have to capture that signal and maybe decode something inside it. So these are the kind of challenges you can expect on level 3. So just to reiterate, the level 1 is only MCQ questions, multiple choice questions. Level 2 will contain some virtual challenges, which is about how do you analyze a particular signal, how do you take a signal, or how do you read a signal, that kind of questions. So most probably you will be using a lot of softwares, but there is no requirement for any hardware. And when it comes to level 3, yes, it does require you to have access to the SDRs. And those of you who have who are successful in going to level 3, an SDR is actually being provided to you by the Indian Army. So you can use that device to actually run your experiments on. And you can once your challenge is finished, you can submit it once you have tested it on your own SDR. So that's about the hackathon information. So you may let us know if you have any queries right now on the chat box. So one of you has asked if you can get previous recordings. Yes, Mr. Sam, you can get. I believe it is already posted on. The. You can just. It's already posted on the YouTube. So I believe you should get it on the ISAC channel of the YouTube. So you can also check the website for more information on where you can get your previous recordings. I believe it's already there on YouTube. Just check. It's ISAC. Yeah, just check ISAC or Information Sharing and Analysis Center channel on YouTube. You should be able to get it. Okay, the time for today's hackathon is 5:30 p.m. So the hackathon is from 5:30 to 7:30 today. Books, I'm not very familiar what kind of books you can get. Uh, Let me just check the Amazon bookstore. Yeah, actually, I'm not aware of any good SDR books actually. Yeah. Yeah, you have lot of resources on the internet. You can definitely read through. Depending on what kind of projects you want to make, yeah, you can just get it very easily. There are a lot of projects on instructables.com. Let me just show you. Yeah, you can just check out instructables.com. So it has a lot of projects. So I personally checked around 40 45 projects in Instructables. I've pasted one just now. Okay, hacking mastery with Kali Linux. I'm not sure if it contains all about SDR. Yeah, Kali Linux, it's good for learning Kali, but I'm not sure if it has SDR concepts inside it. Yeah, you may check and confirm. Yeah. Yeah, Dragon OS. I have not used it particularly, but yeah, you can definitely use it. So I would say Ubuntu is better because there are. I mean, if you're a Linux guy and if you're comfortable with Linux, you can either get a Kali OS or you can just get the Ubuntu OS. Ubuntu may I mean there are a lot of softwares and scripts basically which can help you out. Working with SDRs. So GitHub is also a good resource to see what kind of projects or what kind of code is actually available for various projects and use cases. So you can also search for GitHub to see what kind of projects are available. Okay. Yeah. So please do let me know if you have any other questions on Hackathon or SDR. Yeah, I would recommend you to go to the ISAC website, ISAC channel on YouTube. So in our last week's workshop, there were a lot of demos which were also shown on how to work with the SDR. Hands-on demos on the SDR were also there. So just take a look on that. I'm just pasting the channel here in any way. Okay, the internal server error is it's common actually. So you can just refresh the page and you should be able to continue. Yeah, we are aware of that issue. So most probably you should not face that issue today. Okay. That information is still not available on how many students will go to level 2. So it depends on how many participated. Based on that, a decision will be taken. But this information you can just follow our sdr.in website. All the information and updates will be posted over there. Yeah. So that will be all from our side. If there are no more questions, you can log out. Yeah. So thank you all for attending.